Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. If you have been liking the kinds of videos that I make, maybe you should consider subscribing to the channel. In this particular video, we are going to look into how we can set up a three-node Kubernetes cluster where one particular node would be leader node and the other nodes are going to act as follower nodes or worker nodes. So we are actually going to use this project named Kuberium, and using Kuberium we are going to set up a Kubernetes cluster on those three nodes. Now if we talk about what are all the components that should be installed to get a Kubernetes cluster up and running, let's just go ahead and try to summarize what are all the components that make up a Kubernetes cluster. So the very first component that I would be talking about, or we should talk about, is let's say API server, and the other one is Kube scheduler, and the third one is controller manager. And obviously we would also have a data store, and in most of the cases we use etcd. So these are the main components in the control plane node or the leader node of the cluster. So if we talk about the other worker nodes that we get installed, we have already talked about this in one of the previous videos, but I'm going to talk about that again. So in the if we talk about the other node, that is, let's say, follower node, in that node we are going to need two main things, I would say. First would be kubelet, and another one would be kube proxy. And these two components are actually required on the worker nodes, both of the worker nodes. Now if we talk about Kuberium actually runs these components, especially if we talk about core components. So Kuberium actually runs all these components as pods on the cluster. So all these components that we see here, API server, scheduler, and controller manager, and even etcd uh, is going to be run as pods on the Kubernetes cluster. Now if we are talking about pods, and we know that pods are used to run containers, pods are eventually running containers. We know that, for example, let's say this is the leader node that we are talking about. In here we would also need Docker, and once we have Docker installed, we would also need kubelet in here as well. So we would need kubelet in the master node as well. So that because kubelet is the actual component that talks to the Docker engine that is installed on the node. So that is the reason we need kubelet on almost all the nodes, because we are going to run workloads on all the nodes. Similarly, if we talk about third node, we would need kubelet and kubeproxy here. Similarly, we would need Docker, and we would need Docker here as well. So yeah, I mean, these are all the things that we need to install when we talk about setting up Kubernetes cluster. Now let's look into how Kuberium actually does these things for us. So what Kuberium does is, Kuberium actually, so there is this concept of static pods in case of Kubernetes. So Kuberium actually creates the manifest of these four pods, let's say. And Kuberium actually, after creating those manifests, it puts them into a specific directory, and kubelet is actually configured to look into that directory. And if kubelet finds any pod manifest in that directory, kubelet actually runs those pods. So in this particular case, we are seeing that we don't actually require API server to run the pods. Kubelet independently can run a pod if we put the pod manifest on a specific location. So yeah, this is the concept of static pods, and static pods are used to spin up the core components of the Kubernetes cluster. So for example, let's say if we talk about leader node, we are going to install kubelet, and after kubelet we will also have to install kubectl to actually access the cluster, and kubeadm itself, so that we can run kubeadm init command to actually create the cluster. So yeah, now I think things are a bit clear. So let's just go ahead and try to create these three instances, and we would install everything that we have just discussed about. So this is my DigitalOcean account. I'm just going to create three bare instances, Ubuntu instances. So create droplet and basic. I'm not going to change anything, just Bangalore. And authentication, I'm going to choose password, but you should choose SSH. This is just for demo purpose, I would say. That is the reason I'm just going with a password. I have entered the password. It simply means that how are we going to access those instances. And the very main or very important thing is there should be connectivity between all those three instances. So we want to create three instances. So that's why I have three droplets selected here, and these are the name of the instances that we are going to create. We can change the names to anything that we want to, and let's just go ahead and try to click on create droplet. So after clicking on that button, it just takes, I think, some seconds to get all the instances ready. But meanwhile, we can look into this diagram once again to see what are all the things that we need to install, at least on each node. So on each node we would need kubeadm, kubectl, and kubelet, as well as container engine. In our case, we are going to use Docker. So we are going to install these things on every node. So and we know the reason why we want to install those things. So yeah, it may take. All right, so it looks like it has been all the instances have been created successfully. So let's say we want to create 01 as a leader node. Let's copy the IP address for that node and SSH into that node. Okay, so now we are on an instance that we have just created, and inside that instance, as we discussed, we will have to actually install these things that we talked about. So to install these things, let's just go ahead and try to run these commands. I have written these commands down, and I'll paste them into a GitHub repo. Maybe after when I upload this video, so that won't be a problem for you. So I'm just updating the dependencies and their version. So it's not it's a very basic command, I would say. So yeah, and then we are actually going to install some things, for example curl and other things, but let's just wait for this to get completed. Okay, so it says, I mean, there is this dependency. Do we want to keep the local version? I'm going to choose, I want to keep the local version installed, and yeah, it would just continue with the other dependencies as well. For this one as well, I'm going to choose keep your currently installed version, and yeah, this would progress to install or update or upgrade the other dependencies that are installed on this particular cluster. So I would pause the video for a second and I'd get back as soon as this is installed. Okay, so once that command is done, we are going to run this particular command to actually install these two dependencies. It should not take that much time. Yeah, and we can see that it has been installed successfully. Now what we are going to do is we are actually going to add key. So just to if you want to explain this, for example, let's say in any package manager tool there are some releases for a particular dependency. So just to check if you are installing correct release and things like that, that is the reason we add keys. So that is the reason we are running this particular command. After that, what we are going to do is we are going to add a repository for apt. So again, if we try to relate it with, for example, let's say Helm and Kubernetes, in that case we actually install or we add Helm repositories so that we can install applications that are hosted on that repo. So similarly, we are adding this particular repo for apt, this particular using this particular command. So we are adding this repo here on this particular file. It simply means that we are adding another repo for apt. Now we are going to run apt get update once again, just to make sure that the repo is the new repo that we just have added is being used for apt now. And now we are actually going to run the main command that we have, and this actually installs, as we discussed, kubelet, kubeadm and kubectl. So if you look into this particular diagram, kubeadm, kubelet and kubectl, these are the three things that we are going to install using this particular command. And again, it might take a bit, so let's see. And as soon as we have installed these three things, we are going to install docker. And once docker is installed, we are just going to say we are going to use kubeadm to actually create the leader node. And kubeadm is going to, as I said, create the manifest files, and all those manifest files would be copied to static pod path, and then kubelet would be able to start those pods. So yeah, as you can see here, these things have been installed, and we also want to install docker, as we talked about when we looked into that diagram. And once we have installed the docker as well, let's just go ahead and try to run the other command. And I just want to highlight once again that we are running everything on, as of now, on leader node, but we will have to do all these things on the other instances as well. So now I'm going to run apt mark. It simply means that these dependencies would not actually be updated automatically. So that is the reason we are keeping hold on these dependencies, we can say. So now what we have done is we have actually installed all the utilities, I would say, all the binaries that are required to initiate the leader node. We have installed everything on the leader node. Now let's just go ahead and SSH into the other instances. So the other instance that we have is this one. And let's SSH into the other one as well. So this would be the second worker node. Here we go. Now what we are going to do is, if we go back to this particular diagram, we are going to run kubeadm init on the leader node, so that all the setup about setting up these pods and other things would be done on leader node. But meanwhile, we would actually parallelly install these other utilities that we installed on leader node on these two follower nodes. So let's just go ahead and try to run kubeadm init on the master, or sorry, leader node. So the IP of the leader node that we have is this one, and this is the command that should be used to actually initiate kubeadm on this particular leader node. Now we know that this is the address that is going to be used to access the API server, as the name suggests here. And that is the reason we have specified publicly available or publicly accessible node or instance IP. Now, if we talk about pod network CIDR, it simply means we are specifying the IP range in the classless interdomain routing mode or format. So this is the range of the IP addresses that would be assigned to the pods that are going to be created by our, if we try to install any application. So yeah, this is pretty simple command, I would say. Now what I'm going to do is just going to hit enter here, and yeah, things should work now. And as I said, meanwhile, let's just go ahead and try to install those utilities on these two worker nodes. So yeah, I'm going to do the exact same thing on these two nodes parallelly, and let's see. So it might take some time. I mean, creating the cluster using KubeADM would not take that much time, but the other thing, for example, installing all the dependencies on these two worker nodes would take some time. So I would pause the video, and I would come back as soon as these things are started. And I would just like to highlight that we are going to do the exact same thing that we did on the leader node until kubeadm init. So we are not going to do kubeadm init on the worker or follower nodes. That is just for the leader node. Okay, so things are done, and if you remember, this was the last command, obviously before kubeadm init, that we ran on leader node, and that is what we are going to do, or run on the worker instances. So now if you talk about leader node, we can see here the command was successfully completed, and it says to get the worker instances join this particular leader instance. This is the command that can be run on the worker instances. So let's just go ahead and try to copy this command, and I'm going to run this command on the worker instances, both of the worker instances. Now, and this was the reason we installed kubeadm on both of these worker instances. So now it says that this node has joined the cluster, and similarly we see that message on the other worker as well. Now let's just go ahead and try to run kubectl get nodes on the leader node. So right now we are on this particular leader node, and we are assuming that everything has been set up for us. So, and but this particular thing says the API server is not actually available. And if we look into this log message here, it simply says that to actually set up kubeconfig file, this is what we will have to do. So let's just go ahead and try to run these commands. And now I'm suspecting that kubeconfig file should have been set, and if I say kubectl get nodes, we should be able to see 3 nodes Kubernetes cluster up and running. So yeah, because we did run kubectl join from these two worker instances. Now the problem that we can see is these nodes are still in not ready state, and if we try to have a look into kubectl get pods hyphen and kube system, because we know that all the control plane components would be installed on this particular namespace. So we can see that as we discussed in this particular diagram, kube proxy and all these 4 core components have been set here. So scheduler, controller, API server, etcd, and things like that. Because we have three node cluster, that is the reason we can see kube proxy here. Now Another interesting problem that we see here is core DNS pods are not coming into ready status, and the reason is we will have to install this another I would say project, another tool that actually helps us with the connectivity of the containers, and we call it CNI plugin. So container networking interface implementation should be installed, or a plugin that implements CNI interface should be installed, so that pods would be able to get IP addresses, they would be able to communicate with each other, as well as, for example, let's say a pod is, let's assume a pod is in this particular namespace and another one is, sorry, in this particular node, and another one is in this particular node. So in that case, this particular connectivity would be enabled by CNI, I would say. So for example, let's say if containers are on the same node, in that case they can try to communicate to each other using network drivers, for example v8 and things like that. So yeah, but for other advanced networking, container networking, we use CNI interface, and that is the reason, that is the last thing that we will have to install on this particular Kubernetes cluster. So let's just go ahead and try to run this command. So it simply installs Flannel. If we go to the documentation of Flannel, it's a CNI plugin, and as soon as I install Flannel, now we should be able to get core DNS pods in running state. So kubectl get pods -n kube system, and if you watch this, let's just wait for a second, and we should be able to get these pods in running state in a second. So as we can see here, the status has been changed to running, and if we also try to list all the nodes, we should be able to see nodes are getting into ready state. So now what we can say is, what we can say is we do have a 3-node Kubernetes cluster up and running, and we are on the leader node, and if we run kubectl get nodes, we can see all the nodes are in the ready state. Now just to make sure that everything is actually working, what we are going to do is we are going to install an Nginx application or Nginx server on this particular Kubernetes cluster, and then we are going to expose that using node port service type, and we will access that from outside of the cluster. So kubectl create deployment Nginx, let's create it in default namespace, and -image is going to be Nginx. Now this deployment has been created. Let's expose this deployment, or let's create a node port type of service for this particular deployment. So expose deployment Nginx, and type is going to be node port, and port is going to be 80, because we know that Nginx container or Nginx application listens on port 80. As soon as I hit enter, and let's just go ahead and try to get everything from default namespace, we can see that a service has been created of type node port, and port 32199 of node has been used or exposed. If I just go ahead and try to access the Nginx application, I should be able to do that. Let's copy this port, and here we go. So yeah, and this is the same Nginx web page that we see, same Nginx that we installed on the leader node. So yeah, this was pretty much it what I wanted to talk about. A lot of times people don't actually get to understand, people don't actually know how what are all the things that a Kubernetes cluster consists of. So yeah, if we talk about this particular diagram, these are all the things that are required to run a Kubernetes cluster. Now one thing that I would like to talk about very briefly is static pods. So I said that when we do kubeadm init, kubeadm actually initiates some static pods, and then kubelet actually creates those pods. So by default, the static pod path is etc kubernetes and manifests. And if we ls here, we can see that all these pods are manifest of all these pods is stored here, and kubelet is actually configured by default to look into this particular directory. And as soon as kubelet looks into these directories, it spins up or it creates these pods. So yeah, this was pretty much it. I am going to document every step that I just ran, and I would push that to a GitHub repo maybe. Yeah, that was pretty much it. Thank you so much for watching. I'll see you in the next one.